Stanford University.
Well, great. Thanks everyone for coming out. Always excited to talk to 193P here. It's one of my favorite classes at Stanford these days. My name's Adam Nash. I'm the Vice President of Mobile Products at LinkedIn. And Nick Gillette is one of our lead engineers for the iPhone. And we're going to talk to you today about some of the specifics and details that you run into when you actually try and ship a scaled product based on CoreData. I know that you guys have been looking at CoreData and using it in your own applications and efforts. So hopefully some of this information will be useful for your development. At a high level, I just have to ask, how many of you have used LinkedIn before? Okay. Who here has more than 200 connections on LinkedIn? Dude. 300? No one? All right. Well, I have T-shirts for people along the way. So I think you earned yourself a shirt for sure. I'll throw you one. And I think as we go through the talk, if we have any other technical questions, et cetera, we do have gifts to give out. At a high level, mobile is really, really important to LinkedIn for the simple reason that it's really, really important to professionals, right? Professionals tend to be in jobs where they can afford the most recent smartphone technology. So they're heavy early adopters of the latest devices, whether they're iPhones or other smartphones. And they are never at their desks. So they really depend on their mobile devices to get their jobs done. And so as a result, we've put a lot of effort at LinkedIn in figuring out not just how to make applications that are fun or entertaining, but also how they can be truly useful and help people with their day-to-day business. And our iPhone application really is our flagship application for LinkedIn. Obviously, when you do an application at scale, you run into a lot of unique problems. There's technical approaches that work really well on paper, but then in implementation, as you roll them out, you realize that there are complexities to them. And so one of the things we're hoping to help you with today is what some of those complexities are and answer any questions that you have for us about what you see in the field. So with that, I'm going to hand it over to Nick.
Thank you.
Take it away.
So like Adam said, I'm Nick Gillette. I'm one of the lead engineers on our iPhone team. And I've spent probably the last 12 months or so transitioning our application to actually work on top of CoreData and all of the challenges that entails. Right? So I'll talk about most of those today. I'm going to walk through a little bit of slides and then a lot of sample code, something that I actually kind of hacked together this morning that sort of demonstrates how we view CoreData and the challenges that we've sort of taken on for ourselves in terms of dealing with it. And then I'll go into a little bit more detail probably about our actual implementation on top of it. So with that, there's a couple of key things that we actually learned in dealing with CoreData. And the first is really just understanding your application and the state machine around it. Right? So when data is going to be available to your user, what kind of interaction you're expecting them to have with that data. Are they going to mutate it? Are they going to refresh it from the server? Are they going to take some action that performs a client-side mutation and then syncs that with the server? Those types of things crop up really early on in your design phase, and they dictate a lot of how you think about your state machine inside your views. The next one is kind of scaling for load, right? Adam's account has around 1,500 connections in it. Downloading 1,500 individual people to the device isn't that hard until you discover that it's around 300 kilobytes of data over the wire, right? And trying to manage that in one chunk on an edge connection, a device with really limited CPU power for processing and parsing is quite challenging, right? So you need to design for that. The other one is you need to build your infrastructure for displaying data. Your application is not meant to be a memcache or a server infrastructure, right? It's designed to display data to the user and allow them to interact with that in some way. So scoping the challenges you're going to tackle is critically important because it will dictate what you can deliver. You want to eliminate a lot of the repeated complexity you're going to encounter in your app. And this means asking questions like, how can we make it so that our view controller code doesn't have to worry about sending a network request? How can we make it so that that controller doesn't have to worry about, or the programmer writing that controller doesn't have to worry about, putting the request in the queue, what kind of parameters they're going to give to the request? Are they using a get or a post? We also want our view code to be isolated from the parsing problem, right? Our views deal explicitly with, they deal explicitly with CoreData. And the reason we made that decision is that that means that there's one place they get data, they always know when data is available, and it makes the state machine a lot easier to code because it only has one resource to check. For the most part, our views don't care whether or not there are pending network requests, except to show a loading screen, right? And finally, unit testing. Unit testing I'll talk about kind of as the last thing, but I want to see really quickly, how many of you guys have actually written unit tests in Objective-C in one of your Xcode projects? Show of hands in the back. It's good that your professor has. So I'll cover a little bit of that today, about kind of how you structure unit tests, how you make code that talks to CoreData testable, and what kind of facilities you have to have. And the reason that we do it at LinkedIn, the reason we actually started doing it was we had a crash in production about 11 months ago where someone had a last name with a phone number in it, and our code expected that to be a string. Our JSON parser rightly parsed that into an integer, right? So we had a table cell that was trying to draw itself and discover the size with font of an integer. And that creates a very cool, unreadable stack trace you get back from iTunes Connect. So now we have a bunch of unit tests that ensure that our type serialization is correct, as well that our unit tests and our parsing code path meet certain performance and memory requirements. Right? There are things that are easy about this sort of design approach. Right? Drawing the data model in CoreData is very easy. You put a couple of entities on the screen, gives them some properties, and hook up the relationships. Invoking network requests is also pretty easy. I'll go through a little bit of an NS operation queue based architecture for how you actually invoke and handle your network communication. And responding to request completion is easy as well, right? This is something that a delegate callback can handle from the operation pretty simply. The hard stuff gets down to actually dealing with the data and dealing with what happens to the data after it's been parsed into your infrastructure. So parsing the response into CoreData is one of the primary challenges that we have, because our response objects do not match up to our view CoreData schema very well. The LinkedIn schema is very complex and includes a lot of things. For example, we have the worst one I think is actually our network updates. They're sort of Twitter-like objects. They're tweet-like objects, except that they link to concrete things on the site, like answers, questions, groups, individual people. And trying to structure a data schema that handles all of those distinct types well and allows you to display them in an individual list is quite a challenge. I'll also go over a little bit of the challenges in dealing with threads. If you've used CoreData before, CoreData is not thread safe. You cannot share objects across threads. You cannot even access them from the same, what's called a manage object context from different threads. And so you run into an interesting problem of you have a background operation which is doing your network call, so you don't parse, you don't kill the UI trying to parse your request, and you have to somehow get that data back into the UI context. Finally, I'll deal with the throttling of the request. This is a really hard challenge because unless you run all of your requests through a common queue, you can't control the load on your device, right? You have to ensure that all of your network activity goes through the same NS operation queue. And the reason for that is that you can assign priority to requests and use some of the built-in framework capacities for throttling. Finally, there's the state machine. This is a really hard problem. I don't think I'll touch on it too much today, but without a well-defined state machine, when you're loading data, when data is available to display to the user, when the user has modified data, you can't have a reliable UI. And the reason is that you'll think you can merge things back from your parsing threads when you can't. You'll end up overwriting user changes, they'll be lost, or you'll end up, worst case scenarios, you'll end up crashing because the manage object contexts are out of sync. Right? With that, I'm going to talk a little bit about request load first. How many of you guys have dealt with NS operation queue? I think Sean told me that they hadn't quite covered it in this class. Are you guys familiar with like blocks in Objective-C and Grand Central Dispatch? So NS operation queue is kind of the precursor to GCD. And the big evolution in GCD is that you don't have to create concrete classes to get processing done on separate threads. The disadvantage is that it encourages you to violate a little bit of encapsulation. Right? So the reason why we chose NS operation in this sense is that it allows us to encapsulate all of our network code inside of one layer. Right? It keeps it out of the UI, keeps it out of the parser, but it allows it to run sort of on its own in a structure that we want. Most iPhone apps don't deal with request load very well. They'll sort of, ad hoc send requests off to the server as they need to. The user will invoke some action, in our case, bringing up like the network update screen, which will say, I don't have any data to display to the user. I'm going to go out over the network and get some, right? The problem is that if the user pogo sticks out and goes to multiple views, you end up thrashing the processor. Now, this is somewhat okay if you can get up to about 6 or 7 independent threads on like an iPhone 4. If they're all running in the background, they'll contend for resources, but they won't, halt your UI. On an iPod Touch or an older iPhone, you will park the UI thread in this kind of scenario. The worst case scenario, obviously, is if you actually invoke these requests on the main thread, but that's pretty uncommon. So what we actually do is we inject an NS operation queue in the middle. And what this does is we can control via a property method the number of operations that are actually spinning up on the processor at any one time. So we set it to 2 today. We've also throttled it as high as 8. We've experimented with device-specific configuration. But we found that 2 provides a pretty reasonable user experience with priority-based adjustments. And it allows the UI thread to be able to handle some of the heavier interactions that we have. The nice thing about it is that you can guarantee that you'll only get 2 requests over the wire at one time, no matter how many actions the user invokes that create these requests. Right? Each user action invokes a request, it creates an NS operation, the operation goes into the queue, has a priority, and it spins up accordingly. Is that pretty straightforward? Any questions on that? Okay. So I'll walk through a little bit of code that we use to actually run this. So basically what I've done is I have a simple NS operation subclass, which talks to our mobile server. Now, this is a pretty complex piece of code. So at LinkedIn, we have a mobile server that fronts all of our APIs and talks JSON to our mobile clients. The core challenge here is that we have to use OAuth. And OAuth is a heinous pain in the butt. I mean, it's just, you have to get your timestamps and your signatures and everything, your tokens lined up correctly. OAuth 2, for what it's worth, is a much lighter specification from the client's perspective. It's a lot simpler to implement. But every request we send across has to be digitally signed, right? So we don't want to do that on the main thread. We also don't want our view controllers to have to worry about building these requests. So we created a simple NS operation subclass to encapsulate kind of all of that responsibility. There's some sort of gruesome bits under the cover, but the basic idea is an NS operation has a main method, and that main method is invoked once the queue is ready to process it. It starts it up on a worker thread, it calls start, which calls main, and in there we actually invoke our URL connection. This is synchronous. The code is already running on a background thread, so you don't have to deal with any additional threading here. You've got a worker thread, it's not going to block the UI. You can spin up as much processing power as you need to, and it will process through accordingly. So we just send out a simple synchronous request. After that, there's a little bit of code to post-process the operation. But this class itself doesn't actually deal at all with CoreData. The reason for that is that not all of our operations or our network requests deal with CoreData. We don't store images in CoreData. The sample app that I wrote spins up about, for my connection set, it uses about 160 connections. So it will spin up 160 operations to get their profile pictures once the first result set comes back. But when we wanted to integrate CoreData with it, the question was kind of how, right? Where? We know that we can get data back, we can get JSON back, we need to turn it into CoreData. And so after we wrote the first operation, we kind of went back and said, okay, well, what facilities do we actually need to work with CoreData? And the key things that we got out of the operation queue to do that was that we isolated all the complexity of making requests, right? Everything is encapsulated into that main method. It fires the URL connection. It takes a type-safe object, which has some parameters in it and can do all the digital signing and that kind of stuff for OAuth and send it out over the wire, right? We also got kind of a managed sort of worker thread environment that we don't have to worry about. As developers, that's huge because the framework is taking all the responsibility of managing, spawning threads, making sure that they're initialized properly, taking locks where it's necessary, and giving you some thread local storage that you can keep your local state in. We also get all of our tuning knobs, right? We can tune these things based on priority. We can tune them based on whether or not we actually want them to be running. We can cancel them using the framework. And that's a huge win for us when we look at load, right? The move to CoreData was a little bit more complex. What kind of drove it was that we had a plist infrastructure, right? And this plist infrastructure just encrypted our data into binary plists, stored those on the device. It was about 1 file per logical object. So we had like a file per member. And for about 1,300 members, it would take 5 megabytes or so of disk space, right? With CoreData, it's about 300 kilobytes of disk space, right? So we got a significant win there in terms of the amount of storage capacity we actually needed. The other thing that drove it was we had a lot of object allocation in memory. And the main reason for that was that parsing JSON into a logical structure, like a type-safe object, say a member class or an NS object, is really expensive. It creates a lot of strings. You do a lot of type serialization. And CoreData can manage all of that for you. And it's a lot more efficient about the memory control than we were being. Right? So we would save about, in some cases, 50 to 60% in terms of total overhead and memory that we were consuming. In some cases, as much as 90%, right, in terms of the number of objects we were allocating. That said, we did make a few mistakes when we first started. We had a single NS-managed object context that was stored in the app delegate. And the app delegate is a really bad place for that because oftentimes you'll have things in there that are accessed by multiple threads. State variables for your application, any kind of sort of static local storage people like to put in the app delegate. And we also assumed that all of our view controllers would actually be single-threaded. Now, because you have network operations running on background threads and they're sending delegate calls to your view controllers, you can no longer make that assumption. You have to be very careful to ensure that your UI code is always executed on the main thread and your CoreData code is always executed on the thread that you created it with. We tried media in the data model. That lasted for about an hour once we watched the database explode and the performance go through the floor. And we also have a lot of entity inheritance in our managed object model. So a really simple managed object model looks something like this, right? You have a member. A production object model, like the one that we ship in our iPhone app, looks a little bit different. It looks something like this, right? And this is the heinous network update entity that I told you about. And you can see that we've got a whole lot of relationships here. We're talking to sharing objects. We have comments that are tied directly to the entity. We've got group relationships. And of course, we have like our members, right, which live in our network updates. The reason for this is that this model, despite its sort of inherent spider web-like complexity, actually makes your parsing and your coding a lot safer. So what happens with CoreData is each one of these sort of entities gets turned into a concrete class, so to speak. So there's a header and an implementation file for each entity, which means that when you're writing, and I'll actually open up one of those. So this is what a CoreData class looks like, right? And the nice thing about this is that you can code against this in, say, a table view cell or something that is trying to render on top of this model object in a type-safe way, right? The compiler will tell you, hey, you're using a string when you want an integer, or you're using an integer when you expect a string, right? And that makes your code a lot more reliable sort of as you're writing it, right? It's sort of the first step to unit testing. It's like, let the compiler do what it's good at, telling you when you mess up your assignments, telling you when you're abusing properties, that kind of thing. But that said, most applications don't need a graph that's this complex. It's sort of only our crazy NUS stuff that requires it. Any questions on that? I know I just kind of went from one extreme to the other. Any questions on sort of like modeling or dealing with objects, that kind of thing? Cool. All right. So we use a lot of nested objects, but there's a distinction between a nested object and what's called actual entity inheritance. So entity inheritance is sort of what people traditionally think of object inheritance as, right? You have some super entity, maybe a network update, and then underneath that entity you create an answer update. Now that makes sense in an object-oriented world, right, where you're trying to adhere to strict OO design principles. It doesn't make sense in a database world. And the reason why is because CoreData thinks of things as objects. It thinks of them as concrete sort of objects that have a list of known properties and variables associated with them. When you do entity inheritance, what SQLite or your XML store is really doing underneath you is it's saying this table that represents a network update and this other table that represents a profile update are going to be combined into one object. So anytime you fetch that entity out of the database, you're doing an automatic join, right? And that will slow down your fetches. It's brutal in scrolling, right, if you're trying to scroll through a list of stuff, but it's also pretty brutal anytime you're trying to do, parsing or any kind of search inside the application. Manage object context. So an NS manage object context is sort of CoreData's in-memory cache. Objects are fetched into a manage object context. And again, these are not thread safe. You want to keep them isolated to one thread, and you want to keep any objects that you pull from them isolated to one thread as well. The nice thing is that they can all share a persistent store coordinator, which is how CoreData actually communicates with your store, right? Your SQLite store, your XML store, whatever that happens to be. Finally, with manage object context, you have to be crucially aware of threading, right? You will crash, maybe not when you think you should if you cross a thread with a manage object context or a manage object, but it's a matter of time. So that said, some do's and don'ts. The only major don't is really just don't ever block the main thread when you're trying to manipulate your objects in CoreData, whether it be parsing or searching. Perform fetches on background threads, especially large ones, for our connection search, which can search thousands of objects in the store at once. We actually do that on the background thread, and then we send the result set back to our main thread to populate the table views. You always want to be merging. So CoreData has facilities for tracking what saves are going on in the application. You should use those. There's like NS manage object context did save notification. Those will help you sort of pre-populate the objects in your manage object context you're going to be working with. It's kind of like preloading your in-memory cache. And that's also the last one, which is respond to save notifications as necessary. So now I'll talk a little bit about parsing. How many of you guys have ever tried parsing JSON into an iPhone app? Have you ever used like wire fetching or anything like that to bring data into the application? Not so much.
They downloaded JSON and they used like a free library from that to parse.
Sure. Sure. So usually you parse those into NS dictionaries, right? And have you ever done anything with a dictionary after you've parsed it? Turn it into a concrete object that's type safe, or are you always using value for key? Okay. Value for key wins. So that's actually kind of like one approach, is that you manually sort of get a JSON parser, you parse it into a dictionary, and then use value for key in your model, in your views, to render that information. The other one is you actually leverage the NS manage object model, because the manage object model that you create has all sorts of nifty information in it that you can use. So I'll run with this one because it's really simple. This model basically tells me everything I need to know to correctly serialize my data response. And so I've actually written a quick sort of unit test to do that. And I'll just go ahead and run that, and we can take a look at it. So what I've done is I've canned up a little bit of JSON. And this JSON just actually contains a little bit of my member information. It has my picture URL, it's got my headline and my member ID. It also has my first and last name. And I've written a really straightforward unit test, which basically says, hey, go off and find me that JSON file, and then parse that into a dictionary using your average third-party JSON parser, and then serialize that into CoreData, right? And so if we run the test, we can see that this actually runs a simple shell script that integrates with a framework called OCUnit. And you can see that my unit test case passed. It's a simple method that goes through and checks to make sure that my first name, last name, member ID, and then profile URL are all parsed out sort of correctly, right? Now the reason why you do this with CoreData is to ensure that your actual object model can correctly be parsed from your JSON format. This is a really easy way to validate what you expect, right? That your JSON format maps the model you've created. Now that works out really well if it actually does. There are going to be some cases, like in LinkedIn, where it doesn't. The JSON response does not directly map to that network update entity. And so we have a variety of facilities on top of CoreData to help resolve those discrepancies. But I'll go into that a little bit later. So that's kind of approach number 2. You have a method, it serializes and reads your sort of object model and then parses that into CoreData. There are some questions you should ask yourself too that can help sort of reduce the scope and complexity of what you're dealing with when it comes to CoreData. First is, do you need actually unique objects? We struggle with this one a lot at LinkedIn. And the reason is that our APIs return different types of data. We don't have one API that returns member data. We don't have just one API that returns network updates even. You can get those from several different APIs. And so the question really became, once those objects get into the store, are they unique or not? Right? How are you going to identify them and correlate them to a given view and user experience? CoreData has no built-in facility for uniqueness. It doesn't understand primary keys. It doesn't allow you to fetch objects by ID unless you fetch the fetch request that way. And so that challenge, that's a huge challenge, right? Keeping objects unique in the store. The other is, how much can you flatten your model? One of the things that you saw is that deeply sort of nested hierarchy, right, of objects. There's a lot of relationships. Parsing that is very complex. You have to recursively traverse your object graph and discover whether or not your JSON response maps to any objects inside that graph. That's also very slow. We have some facilities that help speed it up, but in the general case, it's not very performant. And finally, the last one is kind of touched on by the other two, which is, does your wire format map closely to your object model? If it does, that's usually a pretty good start. If it doesn't, you're in for a little bit of a rocky road off the start. That said, does anyone have questions kind of on that side of things before I move on? Cool. Yeah?
You said that CoreData, these issues with unique objects that you have, unless you do the fetch requests using an ID. Why wouldn't you do that?
Well, that's actually the point, is that you have to. Sorry, the question is, CoreData doesn't understand primary keys for your actual model objects. Why wouldn't you fetch them out by ID? And you absolutely would. The problem is that to understand whether or not an object you get back over the wire is already in the store, you have to do a fetch. And that fetch will go down to the disk. It will read. And if you're parsing 1,500 objects, that is very slow. Right? And sometimes it's several thousand milliseconds slow just to unique those objects across the store. So what you generally end up doing is you create a whole bunch of new objects in memory and then try to dedupe in one pass, where you bring up all the objects you've parsed and all of their possible counterparts on disk. Right? Does that kind of answer? Okay, cool. Give that guy a t-shirt.
I guess you still have to do that comparison at some point, right?
Yeah, I mean, there's a couple of ways to deal with that, right? Like what we actually do is we don't unique objects across the store in certain places. And the way that we deal with that is we tie each entity directly to a view, using either a code that maps to that view that we can store in the entity, be it a string or an integer, something that we can map from the view controller and say, give me network updates for the all updates view, right? The other way that we do it is we actually just wipe the store out every time you fetch. So for example, in the few cases where we actually deal with Twitter, whenever we go get a fresh list of tweets, there are cases where we will nuke the entire store of tweets, right? And the reason that we do that is that you don't have to deal with any of these duplication issues. There are other places in our CoreData implementation where it makes sense for us to unique objects. The user's inbox is one of them. Most inboxes are of fairly low liquidity. They don't have a lot of traffic. Whereas a user may get several hundred network updates a day or a week, their inbox will usually see about a tenth of that, right, traffic. And so uniquing objects inside of there is much less expensive, one, because of the overlap, but two, because of the actual data size set is very small. Okay, cool. So I'll go a little bit into more detail kind of about how we actually parse and a couple different approaches to that. So the first approach that I talked about is kind of, you understand the object that you're parsing, and you iterate or you manually pull keys out. I don't like doing that. I don't think that it scales. Can you guys read that, or is that too small?
If you flip the colors, it'd be nice.
Okay. Better? Okay. So I've written a simple parser, quote unquote, that parses out the members that we receive over the wire. And so essentially what this does is it iterates over the list in the JSON response. It's at the key list. It pulls that out and then iterates over each dictionary in that array and turns that into a CoreData member object using this method called parseMember. Now this is a slight abstraction from the normal route. Normally what you would do is you'd say, hey, do you have the value for this key? Set that on my property, right? Or set that on my object. What we do is we actually iterate over the dictionary, the response dictionary, and check to see whether or not a given key in the response dictionary matches a property in the manage object model. You can see that I've named them, first underscore name, headline ID, last underscore name, and picture underscore URL. And that actually maps directly to the wire response, right? You have this wire response, and it's picture underscore URL, headline, last underscore name, and first underscore name. And so in the parser, what you see is that I can actually just iterate over all the keys in the dictionary and then call set value for key on the model object. And then later in my code, I can use the type-safe property accessors to get that data out, right? Now, there is one caveat here, and that is that sometimes data doesn't come back in the format you're expecting it. And so you actually have to do some coercion to turn that into the type of data that your model wants. Now, I happen to know in this case that my model expects everything to be a string, so I can check and see if it's in a string, and if it's not, I can turn it into one, right? Number is called description. This will fail on pretty much anything that's not a plist encodable object. So if you have any kind of custom objects, you're going to have to come up with something more creative. Questions on that? Is that pretty clear? So at LinkedIn, as you can imagine, we have this sort of same problem, but spread out across a much, much wider domain. And so that's actually where we have had to be a little bit more creative and come up with some interesting solutions about how you actually approach this problem, right? So we have some complex code that looks at the actual entity descriptions and figures out what type they're expecting, whether it's a string, an integer, a Boolean, and then we have a set of custom transformers that can transform virtually any type of data we get back across the wire into one of those types, right? That infrastructure was pretty tricky to come up with, but once it's up and running, it's pretty fail-safe. It's also unit testable, which is awesome. So that's kind of parsing with CoreData. Now there's another trick about how you actually invoke this parser and when. I talked a little bit earlier about the sort of mobile server operation that handles all of the request stuff. Well, we made a subclass of that, which basically takes care of our parsing. There's a hook in there called connection did finish loading. It's something that we created so that we can hook into our subclasses and have them do custom processing if they need to. And it's a really nice place to stick that one line of code that actually parses all of your CoreData stuff on the background thread in that managed priority queue, right? Does that make sense to everybody, how that is kind of tied together? Threading and whatnot? So now there's kind of some lessons that I'll talk about a little bit that we learned from our experience with it. I think I've already hit on most of these points. And the first one is that we parse using the NS-managed object model. The reason is that our objects have to be type safe. The type that is displayed to the user, that is rendered out to the user in like a table view cell or a custom view, whatever you may have, must be correct. We can't spend our time defensively coding around every possible type that could come back in the response. The only way to know that information reliably is from the actual model. The model has an additional advantage that if for some reason you decide you need to change your type, you change it in the model and you regenerate the class file. And then CoreData does all the hard work for you, right? Or the compiler does all the hard work for you. We also optionally unique objects. I hit on that one a lot, but the real story there is that it's very complex to ensure that every object in your CoreData store is unique. That complexity is multiplied by threading, right? Trying to unique objects across different threads, which may be parsing the same object, when those objects may not already be in the store, is very challenging. And how you tackle that problem, I don't think anyone has solved yet. The trade-offs that we ran into really is that you can do object and recursive parsing. You can have a bunch of relationships that sort of logically match your response, but those relationships don't necessarily provide a good user experience, and so their value is pretty limited. It's a lot better to find a way to sort of grab the relevant information out of the response than to spend the computational horsepower required to recursively parse your JSON response. Like I said, uniquing, it's very hard with threads. That said, we did save a lot of code. So this is actually our old implementation. The member was obviously the worst one because that has the most data and the most sort of relationships. And we spent about 380, 390 lines of code there parsing it. And that includes things like types, type checks. Is it a string or an integer? Oh, I need to turn it into a string. That includes things like fetching them from our on-disk storage, that kind of stuff. And with CoreData, we actually don't have any parsing code anymore in model objects, right? We also saved about, around about 1,000 lines of code, right? Versus a traditional approach. So that's actually for us where the big win came from, because you write unit tests to cover your 450 lines of code of CoreData infrastructure, and you don't have to write any more, right? If it makes it through that, there might be some edge cases you missed, but you'll discover those pretty quickly. Which brings me to unit testing. So quick show of hands, how many people have dealt with unit testing in some capacity before? Do you care to talk a little bit about it? Anybody? Not so much? Okay. So what kind of things did you have to unit test?
It was Tetris pieces, and then just some general algorithms and other stuff.
Cool, cool. So the response is, yes, they dealt with unit testing, and unit testing is encompassed. Are these model objects, or are they actual view UI objects?
I think these were probably
Views. Okay. All right. So they're mostly view objects. So the iPhone allows you to unit test two separate types of objects, both sort of. Give them a T-shirt. Thank you. It allows you to test sort of. Sure. Allows you to test sort of two different types of objects in your class. You have what are called logical tests, and then you've also got sort of more concrete application-oriented tests. I'll talk a little bit about logical testing today. Application testing is pretty straightforward after you've done the logical infrastructure. So there are a few components to unit testing on the iPhone, and the first is the one that I've already tried to run, which is the testing target. And this target is actually what's called a unit test bundle, right? The tricky thing is that it has to be set up and structured off of your, just like your real application. It has to pull in all the source code, it's got to link in all the libraries, and it has to be able to run just like your real app. Xcode makes that somewhat simple to set up. I won't go all the way through it, but you basically set up a new target, select unit test bundle, and then go in and import all of your class files. To write sort of a logical test, you create basically a new unit test class, In this case, I've created the li member parse test. And if you want to add a new one, you can come in and say, here's a new file. I want a Cocoa Touch Objective-C unit test class, right? And that will generate for you some scaffolding. Application tests, and this is really like the only thing you have to change. Application tests are designed to be run inside of an actual application executable. They'll give you access to UIKit. You can use UIKit inside of those unit tests, which you can't do in logical tests. That's sort of the only caveat, is that UIKit classes will crash if you try to run them inside of a logical test. And then finally, you just have to set up your testing methods. So I created a simple one that tests whether or not we can actually parse the JSON into the actual model object. And to do that, I had to do a little bit of file system stuff, but it really just comes up to how you structure your data and how you store it on device. And then you can use these simple asserts. There's a whole bunch of these, like NS assert. I use true a lot because a lot of times, like st assert equals, we use equal, and that doesn't work out in Objective-C land. That's kind of it as far as like setting up unit tests. Now, the one thing I did actually want to show you is sort of a little bit more about what you can do with unit testing. And I won't run these because some of them require network activity and they do take quite a long time to run. But in our iPhone application, we have a pretty extensive set of tests, right? So we can actually unit test both parameterization of requests, so making sure that they're generated properly. We can also test actual requests going out over the wire, right? And one of the ways that we do this is we invoke the request that we want, store it in an IVAR in the test itself, and then sleep the thread that we're working with. Because our request queue goes off in background threads, we can safely sleep and wait for the request to come back to see whether or not it succeeds or fails. This is actually the main way that we test that infrastructure, making sure that requests are prioritized correctly, and then also making sure that they come back as we expect them to, right? A little bit more about CoreData. We have a pretty extensive set of parser tests, both to deal with our model objects. So you saw that heinous network update graph. Well, there's a corresponding set of unit tests that actually make sure that that whole update graph is parsed correctly, right? And the way that we do that is using some canned data and then structuring a unit test to evaluate that specific use case, right? We have a generic test which makes sure that the update itself is parsed correctly, but for each type, we want to make sure that the properties are parsed as they should be. And as you can see, one of the big wins with CoreData here is that we can actually access those by type-safe property accessors, right? That makes your unit tests a lot more reliable because you're not fighting the type coercion. You know what type you expect it to be. If it's not that type, it's obviously a failure because the parser failed, right? A little bit about how we actually store this stuff. So for our unit tests, we actually can up a significant amount of data. And the reason is that that's reproducible. They're always running against the same test, so we know if they fail. But we also do make live calls to our mobile server to fetch data from the LinkedIn network, which they kind of hate because they see this big traffic spike of like a couple of thousand calls in a minute. And that they'll get like freaked out about who's spamming them. And it's me at home running the unit test. But some of these files are a little heinous. This is a list of network updates that we have canned up. And you can see like the response here is actually pretty complex. This is a nested graph of objects that comes back in a JSON response. So here we have like this update happens to have a person in it. It looks like it's a picture update, has some Booleans that we need to parse out. And it's also got, this person then even has nested objects inside of, that response object. So we end up parsing those out using the CoreData relationships. That's sort of unit testing in a nutshell for us. Are there any questions I can answer for you on that? So the question is kind of like at LinkedIn, how do we divide up our code and our actual CoreData management between our view controllers and our parsing code paths? And the answer is we keep them completely separate. Our view controllers talk to one manage object context generally. Some of them have their own based on specific performance requirements that we have there, like memory management and fetch speed and that kind of stuff. But the parser operates completely independently of that. And what happens is once the request is done, it will make a delegate call to the view controller saying that its data is now available. Other than that, they're not integrated, for the most part at all.
So do different people like write the core data and then someone else like the core data model and does the views and then someone else?
Yeah, so in terms of how we structure the team specifically, we all wear multiple hats, but when we're implementing certain features, we will actually divide up that kind of work in that way, right? Like for this most recent release, I ended up writing a lot of parsing code and unit tests and stuff like that, while some of the other guys spun up on actual view and table cell implementation, that kind of thing. That's a good way to do it, we found, because combining those two in your head is pretty hard, and sort of keeping separate, like, what thread is this coming back on, and should I really be doing this in certain situations is pretty challenging. That's all I've got, if there are no other questions. Cool. Thanks for your time.
For more, please visit us at stanford.edu.